Assalamualaikum and a very good day. I bid to Dr. Isni Maria and friends. Today, our group, which is Group 1, will present the report on Project Visdani Title 1 on topic. We are a group consisting of 3 members, Nur Farisha Erdina binti Muhammad Farid, me myself, Adana Suhab binti Muhammad Nasir, and Hafiz Nur Izzuddin bin Jimat. For the introduction part, the water delivery system for the proposed hilltop bungalow presents distinct challenges, prompting the need for an innovative solution tailored to its elevated location, which is 150 meters. These introductions will lay the groundwork for an innovative approach. The household water supply is designed to address daily needs, utilizing surface reservoirs that store water overnight to meet the peak demand periods. To ensure water availability during the peak demand hours, the surface reservoir will accumulate and store the water overnight. Typically, the highest water consumption will occur during the personal hygiene, cleaning, food preparation, and also the clothes washing hours. Analyzing these variations in daily water usage, the system incorporates sequential pump operation and balance storage. The successful implementation of this water distribution system will rely on the optimal pump selection, fluid mechanical calculations, and also sustainable energy consideration, all of which are crucial for overcoming elevation differences and addressing environmental factors specific to this project. Next is the problem statement. We figure out that there are several problems that might happen in order to build a water delivery system for this project. The first problem is the leakage of the pipelines due to the elevation and distance of the bungalow from the water source. The construction of pipelines that carry water upstream for this project can be complex. The pipe laid on the slopes are exposed to different pressures due to the different heights. This will increase the stress on the pipes, making them more prone to leaks over time. Second problem is the water demand and the quality due to the seasonal changes. If there is no rainfall for a long period, water shortage will occur, which cannot fulfill the requirement of water supply to 50 people during the peak demand. And also, due to the topography condition of the hill, it will be more difficult to pump water into it. Water pressure can be low at high altitudes, which can impact the flow rates and also the water quality. Hillsides are likely to be harmed by runoff and also erosion, especially during the heavy rainfall. This will allow the sediment, debris, and also pollutants to enter the water source and affect the quality of water intake from the pond. And the degradation of the water quality in the pond will influence the water parameters like the turbidity, oxygen solubility, and contaminant levels. The last problem is the costing of the construction of a pipeline system to transport the water. This project requires some significant costs, including the installation of pipelines, pumps, and also water reservoirs. Numerous considerations need to be taken, such as the material and sizings of the components, construction techniques, and also pumping requirements. We move to the objective parts. In this project, our objective is to design and construct a practical, adaptable, and efficient water delivery system that ensures a steady flow of water. Second, to overcome the obstacles caused by the harmful environmental conditions and unpredictable weather events. And last, our objective is to achieve the consumer satisfaction by providing a sustainable and cost-effective water supply system that capable of meeting the quantity demand. For the scope of this project, the scope is to manage the supply of water from the pond nearby to the bungalow that is located at the top hill, and to figure out the daily water demand of the consumer in the bungalow in order to analyze the pattern of water consumption. And last, our scope is to determine the cost estimation of the project after considering the type of equipment used, the dimensions, materials, quantity, and others.
Assalamualaikum and good morning, Dr. Ismi. This is our project design. That in this plan, you can look that we have planned to use the two type of pump. Instead to the two pump that one of the pump is from the water point to the Hughes reservoir 1, and another one is from Hughes reservoir 1 is must take the water from Hughes reservoir 1 to the Hughes reservoir 2 at the top of the hills. So we must to find the power of the pump, the type of the pump we must use, and the flow rate of the pump that must available for the 15 users of people. So based on the problem statement that we have, we have three factor that we must to consider. That is a Bernoulli equation. The second is continuity of the equation, and another one is Reynolds number. The Reynolds number is the flow rate, the flow of the water point from the water point to the top of the hill or peak. So we must to consider the three of factor for calculate the cost, power, and the flow rate that we must use in this project. And the next slide, we have the HL measure, the head loss major, head loss minor, and the pump power. So we must to use this three of this formula to calculate. We must use three of this formula and relate to the Bernoulli equation, and to get the pump power and the head loss major and head loss minor for the water in the pipe from the water supply, from the water point to the peak of the hill. Okay, for the next slide is NPSH and NST. So for the NPSH is the net positive suction head. This calculation for we now the head for the head where the pump must place to reduce the cavitation. And for the NST is the calculation for now the type of the pump we must use in this project.
These are the types of material that we use in our project. The first one is ductile iron pipes. Ductile iron pipes are preferred over other types of pipes for water supply systems due to their exceptional durability and longevity, high tensile strength, flexibility, cost-effective installation, low maintenance requirements, versatility, and adaptability. Next, centrifugal pump. The reason that we use centrifugal pump because it has a lot of advantages, and the advantages of this pump is it is suitable for large discharge, it doesn't require any valve, and it allows to run at higher speed with minimal maintenance. Next, galvanized water storage tank. We choose this material because of its durability and longevity. Stainless steel tanks are more durable and less likely to develop leaks. They are also impact, fire, and corrosion resistant. Next, because of its longevity, stainless steel tanks generally have a longer service life compared to plastic tanks. And the last one is water separator filter. Water separator filters are not commonly used in household. However, since our water source is from pond that might have impurities or poor quality, water separator filter helps remove sediment, sand, and others in the water. This can help improve the taste and odor of the water. This is the cost analysis of our group project. For centrifugal, the unit cost is 206 ringgit Malaysia, and we use 2 pumps, so the total cost for pumps are 412 ringgit. Next, water storage tank. It costs 1 ringgit 23 cent per liter. As we use 2 different volume of storage tanks, the total costs are a bit different for both tanks, which for 5,500 gallon is 30,660 ringgit Malaysia, and for 6,000 gallon is 33,112 ringgit Malaysia and 80 cent. For water separator filter, the unit cost is 367 ringgit Malaysia 72 cent. And last one, which is the crucial material in our project, is ductile iron pipes with 60-inch diameter that costs 140 ringgit Malaysia per meter. Since our total length of pipes are 1,860.34 meter, the total cost of ductile iron pipes are 260,447 ringgit Malaysia and 60 cent. Hence, the estimated total cost for our group project is Rm 325,012 cent. These are the list of references that we referred to during this project. In conclusion, water supply projects must embrace a service model that guarantees high reliability in water deliveries. The project's materials and equipment encompassing pipe sizes, pipe materials, pump types, tank sizes, and pump heights were judiciously selected by employing fluid mechanics principles such as Bernoulli's equation, the continuity equation, and the energy equation. This project carries significant importance as it directly pertains to our daily lives, involving the application of numerous logical assumptions to a certain specific parameter values. In essence, our project successfully devised a water delivery system capable of meeting the needs of 50 people during peak demand. Our primary objective is to provide optimal facilities while minimizing costs. All the calculations and insights derived from the study of fluid mechanics were effectively utilized to confront and surmount the challenges encountered in the project.